Existing methods to animate 3D dense crowds typically divide the process into two stages. First, the global position of each agent is computed, and second, detailed 3D motions are added to animate the crowd. However, this causes severe artifacts in the final animation because interactions between 3D bodies are neglected, producing unrealistic collisions between the individuals of the crowd. To address this shortcoming, we propose a physics-based method to resolve collisions in highly dense 3D crowds. To this end, we approximate each individual using a parametric 3D set of volumetric proxies, which allows us to resolve collisions while maintaining the overall motion of the crowd. Resulting animations showcase for the first time collision-aware 3D dense crowds while keeping the realism of the input animations. Here we visualize the collision-free animation of 6 agents per square meter and their corresponding 3D volumetric approximation. We demonstrate that our approach significantly reduces the character volume overlap, even in highly dense 3D crowds. Quantitative evaluation shows that our method scales well to highly dense crowds in stationary and non-stationary scenes. We validate our approach with an exhaustive perceptual study. To this end, we use an stimuli consisting of crowds rendered from 4 viewpoints for 5 different crowd densities. For each viewpoint density combination, we generate an animation using a baseline method and our method. Furthermore, we also include walking crowds to validate the effectiveness of our approach in non-stationary scenes. For example, here we show a sample corresponding to a crowd of 5 characters per square meter rendered from an overhead viewpoint. Another sample of the stimuli, generated using our method for a crowd of 6 characters per square meter and a frontal viewpoint. And a non-stationary sample of the stimuli, showing a moving dense crowd from overhead viewpoint. Participants use this GUI to answer 6 questions for each video of our stimuli. Extensive analysis of the perceptual study demonstrates that resolving collisions is key to improve the realism on 3D dense crowds. See paper for details. Here we apply our method to a motion capture sequence where a person walks through a dense crowd. Despite that the sequence is captured, baseline methods fail in faithfully reproducing the motion due to collisions between actors. This demonstrates the effectiveness of our approach to synthesize realistic 3D dense crowds. Here we show another captured sequence viewed from the top. Finally, we demonstrate that our method also enables the real-time interaction of 3D crowds with rigid obstacles. Each character is trying to match a target motion, while adapting to the constraints due to the collision with a sphere. This can potentially enable the realistic interaction of a dense crowd with dynamic changes in the environment. Thanks for watching.